So this webinar is about Picador, and I will let Michiel tell you all about that.
Okay. So as David said, today we'll be looking at Picador. I'm going to be focusing on, let's say, variables within Picador. It's called parametric design. So that's design where you can create your packaging design, you make your CAD drawing, but then you create some parametrics, some variables that determine, for example, the width, height, and depth of the box, which can then influence your drawing. So your entire drawing is changed depending on the value of those variables, and you get a new box with the new values that you like. I won't be doing a complete demo of Picador. There are several videos on YouTube already that show you all of the modules and all of the details, but I will be going through the Paclip application and then the 2D application, and if somebody is interested in seeing the 3D as well, I will also show that. So like David said, please interrupt me if I am unclear, if you have questions. That's the style of meeting this is, and it's nice to be able to answer questions while we're on topic rather than having to go back afterwards. If you're not familiar with Picador, Picador is a packaging CAD application from a company called treeDiM from France. They come with several modules. One of these is the one that is open right now, and that is Paclip. Paclip is essentially a database that contains already a whole lot of packaging designs, some of which are standards like FEFCO, but also some of which are originals made by treeDiM for some customers or just for fun. And you can see these are, for example, some furniture designs that are made from cardboard. So if we go to FEFCO, which is one of the biggest parts of the library, you can see it is divided in several subcategories, and each of those is again divided in each of the designs within that category. And in each of those folders, we will find a 2D file, a 3D file, and a technical specification for that box design. If I open up the 2D file, for the standard FEFCO 201 box, you can see what it looks like. Most people know this design, and it also already contains some dimensions. Now, these dimensions, of course, are the part that is variable. That's the interesting part. Most, not everything, but most of the designs that are within the Paclip library are already designed to be parametric. That means that on the right-hand side of the screen, you will see this part, which allows you to change certain variables. The first variable is the thickness of the cardboard you want to use, which is important because the thickness of the cardboard will influence the final dimensions of the box. So we will see that if we change this from reference profile to 1.5, some values will also change. The entire drawing will change size. For example, this value, I'm not sure if that's legible on the screen share, but is 402. If I change this from 1.5 millimeter to 5 millimeters, it becomes 405. So it didn't just increase by the same difference we have for the profile. It's smarter than that. It's based on formulas and mathematics that tell it, well, if the thickness is that much, we will need to create a width of this pane that is 405 to work with that thickness. The dimensions we see here are the outside dimensions, where the actual folds are. You can see in the parametric here on the right, it says the length of the box is actually 400. So it changes the 400 to the 405 here between the folding lines, because it is taking into account that thickness of the cardboard, which will take away a part of the box size when it's folded. So the inside dimensions have been made to be the variable in this case. I can change this 400 and I can make it 500. And then my entire box becomes longer. So that's what the parametrics are for. I can change the width and I can make the width 250. It changes again, and I can change the height and I can change the height to 100. And you can see we can impact this box quite a lot. Then there are some more parametric, some more variables we can influence here. For example, the process here, it says slotter right now. This is about the slots here in between the flaps of the box. Right now, these are rectangular. So if we zoom in, we can see these are rectangles. I can change this to die cut, which will change the drawing and will make them round. You can see this is also something that's possible. It can influence a whole part of the drawing instead of just the size. It's a little bit more complicated, but it's also something that we can influence with these parametrics. Then we can have some glue flap control. It's about this flap on the side here. It's right now 25 millimeters, but I can change that to 50 and make it really big. So I can make this box really ugly if I change everything up like I'm doing now. So this kind of variable input is available for, like I said, most of the designs in Paclib. So also the more complicated ones. If I go to, for example, the 400 series, we get boxes that are a bit more complicated. I can open up this one and then the drawing, and you see we still have this design, but it has several more options. And we can go over each of these, and if we hover over them, it will show you what is being impacted by the option that I'm hovering over. So these parametrics are also available not just for the simple designs, but also for the more complex ones. Of course, the more complex the design, the more complex the formulas are likely going to be that you want to use to determine the size of each of the flaps. If we look at how far this can go, the best example is really the smart assembly. This is a separate thing inside Paclib. So besides all these ready-made designs, you have smart assembly. And smart assembly is kind of the ultimate form of parametric design. I like to use the smart box because there it's the most visible and the differences are most dramatic, but it's kind of the same thing with the smart case, which is for the FEFCO cases like we just saw, the 201s, and smart double wall. It's kind of the same thing. So if I go to smart box, what you'll see is we have this design between quotes that is basically the four sides of our box and the glue flap. That's all we get. Now we can change everything else about this box ourselves. So we can set a thickness. Right now it's 0.5 millimeters. That's because it's a folding carton box, so it's not very thick. We have a length, a width, and a height. And you can see when I hover what changes and how the design is impacted. And then we just have top style and bottom style. Now, if I take the top style and I change it from sleeve to tuck end, we will see a whole part of the drawing is being added to it. We get this whole extra addition at the top. This is called a sub-assembly. And these sub-assemblies are just separate designs that are also parametric, that have been added into the codes of the design we have to be stitched together with the artwork we have. So this is a simple tuck-end. You see, we actually got more options now. I can make it more complex, and I can add, for example, one of these lock tongues to it. And we get this extra assembly over here, but also this one has changed, and it now has an extra slot in the folding line here where this lock tongue can be entered. So we can add that as well. Then we can look at the bottom of the box. We see we have several options here as well. And we can use, for example, the semi-auto snap lock, and we get a whole extra bunch of stuff at the bottom. Now, let's say that is not what we like to see. We could also just make it an inversed tuck end and copy the top side, but in mirrored, or we could use the crash lock, which looks like this. So we can go through the options and actually create the design we want. Now, if I decide that this is the top and bottom I want, but the size isn't exactly right yet, I can change these, and you can see that everything still changes along. And it still goes along with all the variables I want to enter. So this allows you to essentially create a box based on the exact requirements you have or your customer has or whatever. You can just start from scratch, create this box. This took us, what, 2 minutes to create? And it's all based on the exact requirements we have for this folding carton box. And that's kind of the ultimate goal of using these parametric designs, is to be able to take something you have, a design you have, and just enter the values you want for it. And then the entire box becomes exactly as you like it. Now, it's nice that they offer all these things in Paclib, that you have the option to just pick your FEFCO design and use parametrics to create the design in the size we want. And that is probably the thing people use Backlib the most for. But we can also do the exact same thing in the 2D CAD application. We can do this ourselves. We can create our own parametrics on our own designs and then use those as variable sizes. I'm going to go over to the 2D application now. So this is kind of the end of the Backlib demo. If anybody has any questions about Backlib, feel free to put them in the chat or unmute yourself and speak up. I don't mind answering questions in between.
So just to be clear about that, Michiel, you actually didn't do anything to get this far, right? You just took whatever is installed in Backlib.
Yeah.
Because you talked about mathematics, but you don't need any mathematics to get to this point.
For this, no. No, until this point, everything is already done for you. So these parametrics have already been created, and you can just use the parametrics and create the sizes you want. I see in chat we want to see a different box. Sure, that's not a problem. We can go to the FEFCO again. I can, for example, take the 300 series. This is also an interesting one because it usually contains a bottom and a lid for each of the boxes. So if I pick, for example, one of these, you can see this one consists of 2 parts, and we still only have 3 variables. We have length, width, height, and thickness, so I guess 4 variables. Now, if we change something here, we'll see right now, before I change anything, this side has a width of 405 millimeters. This one has a width of 404 millimeters. So we see that one of these is created to be the bottom, one of these is created to be the lid of the box. But the length here is still 400. Now, if I change this to 450, we see that both sides get changed, and both sides get their new size based on my new input value. So that's another example of a box we can do. It's pretty much the same story for everything that is in FEFCO, for most of the stuff that is in the ECMA library, which is a library like FEFCO, but for folding carton boxes instead of corrugated, and some of the other stuff, but most of the other stuff is not parametric. So once we go away from this place, well, what we could do is, if we look at a production standpoint, is simply click this button here, which takes our drawing with the sizes we just entered and adds it to the Picador 2D application. So now we're in the CAD application, we can see the actual technical drawing that we have. We can change it still as we want to with the tools we have available here in the CAD application, or we can use this file and send it to production and just produce the box. Now, it's a bit easier for me to start with a blank slate if we're looking at the CAD application. If you're familiar with CAD applications, it's just a way to draw your boxes. You have a bunch of drawing tools, which are on the left here in Picador, that you can use to simply draw a shape. Let's say I want to draw a shape. I can use the origin. I have a Y and an X axis here. If I go close by with my cursor, you will see my cursor change. It actually attaches to that origin. So if I click, you see my rectangle starts exactly in that origin. And this allows you to be really accurate, because you can always have your cursor and your drawing tools interact with other lines that are already present, and also with construction lines that will not be part of the finished technical drawing, but you can use them to be very accurate with where you draw your lines. Now I can drag this rectangle open and closed, and if I can just press the X key on my keyboard, and then I can enter how big I want this rectangle to be. So I can say I want this to be 100 millimeters wide, and I can have it 50 millimeters high, and then just say confirm. And now that is the size of the rectangle I have on the screen. Now, is somebody asking a question?
No.
Okay, I thought I heard someone speak up. Okay, so we have a rectangle on the screen that is that size. We can check that. We have measurement tools here for dimensions. I can simply select my lines, and I will get a dimension. This is 100. This is 50. Perfect. So now what we can do is we can make the box parametric. We can say, instead of having these fixed values, 150, I want to be able to decide the size of the box variably. This is a very basic version of what a finished packaging would be, right? It's just like the most simple shape I can create here. Now what I can do is I can use these purple tools at the top to create a parametric design. I'll use the same tool that I use for dimension, but the purple one for parametric, between parallel lines. Now I pick the same lines, I tell it this line and this line, and I say, well, this is supposed to be the width of the box. I will abbreviate that to W, so this is the width. I'll do the same thing with top to bottom. I have a new dimension line. This is the height, I guess. It could be the length, the depth, I mean, but in this case, I'll call it the height. I'll abbreviate that to H. There we go. So now we have two variables in this design. Now what I can do is I can add my formulas. I can add the math to this if I want to. And I use this formula button for that. I click the formula button, I get this empty field in which I can type, and I can say, well, I always want my height to be equal to my width divided by 2. There we go. So that's kind of what it is right now, but it's only the case right now because that's how I drew it. I can make this work with any size I want. So if I just enter this, I say confirm, I can place this on my field somewhere and we can see my formula. Now I can use the define parameters field here, which will open up a table, and you see it's no longer asking for my height. It's just asking for my W. Why is that? Because it already knows that my height is going to be equal to my W divided by 2. So I only have the W that is necessary as an input right now. I will make this width, and my default can be 100. That is fine. I'll say OK. And now we see we get actually a new part, W equals width is by default 100. And that is the only thing we need right now. And now I can check if it does what I want it to do by clicking on Generate Parametric Component. I get a new pop-up screen, and this is actually what's happening. So all the things that I did right now, the rectangle I created, the sizes I input, the formula I made, and then that I said that the width was going to be 100, is all in here in this bit of code. So if we look here, what's in here, we see this one, W width is 100, 0. So that's what we have. And then if I look a little bit lower in this code, we'll see that we have a variable, W. We have a formula, which is H equals W divided by 2. And then we have all the segments that are being drawn and all the coordinates on where they're being drawn. So with this rectangle, this is a fairly simple thing. People who can read C#, this should be C#. So if you can read it and if you can write it, you can actually just go in and have fun. I have to enter a name, so I'll call it rectangle. I have to give it a description. I'll also say rectangle. And then I can say generate. And now we will get something that we already saw in Paclib. We will get our drawing, and we will get our variable input. You see it's asking for width, which I can change. And if I change width, you see that the height is changing along. So if I make this 150, we see that this becomes 150 and this becomes 75. It's also asking for thickness. Why? Because your cardboard will always have a thickness. So I don't have to define that. I don't have to say, well, you have to take into account that there is going to be a thickness, because Picador does that for you. It always knows that there's going to be a thickness. And by default right now, it took 0.5. I can change this however I want. It's not going to influence anything because I haven't told it to use the thickness in any of my formulas. So I can say, okay, this is what I want, and then I can validate it. If I validate it, it will ask me to save this file, and then I can, or it should have asked me to save this file. Well, it probably did, but it did it in the background. So it saved this script as a file in the background in a folder on my system, and that folder can now be loaded into Paclib, and then my rectangle can be used in Paclib. So that's how you would create your own things. Now I can make this a lot more complicated. Instead of just going with a rectangle, I could say, let's not save that, there we go. I could create something that is more like a box, or even better, I could just go here, go to that smart box that I was making. So I'll make something with a tuck end and a semi-auto snap lock. Yeah, that should be fine. This is already slightly complex. Maybe I'll just go for an inverse tuck end here to keep it simple. We'll keep all these dimensions and I will take this to 2D. So the moment I put this in 2D, this is no longer parametric. This is now your drawing based on the design that we had here. Let's pretend that this is a design that we just made. That is this one. Let's pretend we just drew this up right now. I could draw something, but it wouldn't be this pretty. And we can now create, when we have our own design that looks like this, we can now create those parametrics ourselves and we can make that work. So I would go to my purple tools and I would use the parallel tool to say, well, this, let's start in the middle here, is going to be the width of my box. So that's definitely the W. This is going to be the height of my box. So that's again H. And this is going to be the depth of my box, D. Now I have to make sure that every size that I want to change when I look at the packaging also has one of these. Because just because I made this face of the box W and H doesn't mean that this face of the box is going to know that that is the case. So this will stay the same shape while this is going to change. So I have to make sure to also say this is W and this is height.
And you just have to give it the same name and then it refers to the same variable.
Yes, exactly. So as long as I identify it with the same character, so with the same name exactly, it will know that that is what you want to do.
Okay.
So even though I'm using H 4 times here, and it might not actually be necessary to use H 4 times here. It might be that if I just use it here, that it will automatically take all of these and change them. And I'm actually making a mistake, I think, because I have two different heights. You can see that the heights for the sides is slightly shorter than the heights for the center and back. That's because it took a little bit extra here for that for these flaps to be able to fold in. So I should change this because this is not going to work. I should remove these two and change them into a different value. And I can just make them parallel lines again. And instead of saying height, I will call it HS, height of the side of the box. So I use HS on this side as well. And then I don't have to necessarily tell it later, HS has to be this. I don't have to do that. I just make a formula that says that the HS equals the height minus cardboard thickness, and that should be perfect. So what do we still have? We still have the height of the flaps and these two. These should be pretty easy as well. I'm going to use the cutting line as the thing here. This is also normally the same as the depth, right? Because it has to fold over the depth. So I can make this the depth. I use the cutting line, so it's going to be fine. I already have the difference here for the folding line. So this is just depth. I'm going to do the same thing here. Just use these two lines and call it depth. And then I can make these flap, so I'll call it F. Of course, you can use whatever naming conventions you want for all of this. I like to use single letters here because it's going to make writing the formulas a lot smoother. And I don't necessarily have to add another parameter for this, but I could if I want to make those fold-ins have a value as well. So now this looks a lot more complex with all the purple on it, but if we look at the input, the defined parameters, we see we still only have 5 things that we have to answer for. And this is not even completely correct because actually we only would have 4 if I create a formula that says that my HS is equal to my H minus TH1. And I'm using TH1, which is an undefined parameter for us, but which Picador knows means the cardboard thickness. It's always TH1 for cardboard thickness. So I can say confirm. I add this to the side here. And now if I open this up again, we will see that it's asking for TH1, which we will make 0.5. 0.5, there we go. I'll add it to the sides. And My mouse just stopped working. Oh, okay, that's convenient. There we go. So now we have all these values defined. And if I select the generate parametric component, we'll see that it has a lot more information now. So here in the top, we'll see that it contains F, TH1, D, W, and H. And it only has one formula, so formulas will still only be one, which is HS equals H minus TH1. I have to give it a name and description, which it has, so I don't have to worry about that, and I can click generate. We see something isn't going quite well. It kind of broke off those curves. So I might have to check in adding something to make those curves work. I can say close, close. I think maybe if I do add these last things here, and I call it maybe I for inserts. Let's do that over here as well. It might actually work now. Okay, so it's telling me I need to have a value for I. Okay, that's good. Okay, generate. And now it did work. Okay, so I didn't know what to do with those curves because I didn't make a value for that height here. So now you see TH1 is no longer in the list in my variables here. It just became thickness because TH1 is the default name for a thickness variable. And what do we have? WHDFI. They're all shortened because I didn't add the full names. If I click this and I say I want W to be width, I want H to be height, I want D to be depth, TH1 is already thickness, shouldn't worry about that. F is flap, and I is insert. Okay, we can put that somewhere, and then generate again, and now we'll see all these names have been corrected. And now if I change any of these values, you'll see that everything changes along. Oh, it looks like something is going wrong up there.
Yeah, you haven't put the inserts at the top there, I think.
I think I added them, but I think I made them connected to the fold line and not the cut line, and my other height is connected to the cut line, so it's breaking them apart when they're not changed equally. But you can see this is how it works. You just create your drawing, you create the formulas that you want to be smart, and if you look at the more complex things, actually what we should have done here that we didn't do is we didn't take into account the thickness for all the fold lines here. So really, if we go completely correct, what we have here in between these lines is not actually the width of the box. It's not the width that we want to enter anyway. We want to enter our final inside dimension. So what that means is that our width that we want to enter, actually we wouldn't be using a width here. So I'm going to erase that again. We would be using a maybe W1. Let's call it W1. W1. And now I can say what W1 is actually supposed to be is, well, W1 equals W, which is what we want to enter in the file. And then we have to be smart about this. Normally, you lose around half a cardboard thickness for each fold. So which means we lose half a thickness on both sides, which means just minus TH1. And that would be the actual value we would have for the width. And we can enter the width, but it would actually create a box that is slightly bigger, that is one cardboard thickness bigger, because you have to take into account those fold lines that fold in. And then the more complex your drawing, like we saw in Paclip with the more complex designs, like in the 300 here, there's a bunch more drawings. If we go to the really complex ones, we'll see that there's, well, a lot of lines that you have to take into account. I'm not sure why nothing is showing up in these folders. Maybe there's not a design in there, but the designs can get quite complex quite easily. And the more complex your design, the more things you want to take into account, the more flaps and faces, the more work you will have to create a parametric design. And so far, all we've done is essentially change the width, height, and depth of the box. We've only done the same thing we do here in this first box that we opened. We only did this, length, width, height, essentially. It can be smarter than this. It can actually do more than this does. Because we saw in the smart box that we can, for example, add extra information to the drawing. We can do that as well. The only thing is, that is not made easy the way that we can do this. There's no button to say we want to add, for example, a hole in this box, or 2 holes, or 3 holes. But if you make a tray and the tray size changes and you want to have holes in that tray, you probably want more holes in a bigger tray. So we want to make variable that if the tray becomes bigger, the extra holes are created and they are spaced differently, they are located differently. And that part is not been made with an interface by treeDiM. Why? Because they didn't want to limit the user to use only what that interface would be able to offer. They wanted to allow you to use the full power of what they designed, which is essentially the C# code that is being written when we do this. So what you can do to do that is you create your subassembly, for example, this part in the backlip application. And then when you have the subassembly, you can insert that in the C# code, and you can design where it's supposed to show up, based on what and how often, and you can make your own formulas in there. You can say, I want 2 holes if my box is bigger than 30 centimeters. I want 3 holes if it's 35 centimeters, and so on and so on. I'm not going to show you that because I actually am not that good in the C#. So I've done it before. When you know what you're doing, it doesn't seem to be that hard. And as an extra bonus, if you actually purchase Picador and you have a support and maintenance contract, and you're able to describe what you want to do, the people at treeDiM will gladly help you with your design. So the only thing they want is that you provide the drawing, so you provide the design, and you provide a detailed, clear explanation of what you actually want to do with it. Not just, I want to add more holes. You have to tell them, I want to add a hole for every 5 centimeters, so much spaced apart, centered on the packaging, for example. And then they can turn that into code and they can make that work for you. There's a question coming in. If you want to use a very thick material, 3 or 5 millimeters, you must think in the inside measure on the outside ones to make the design and parameterization. That's your choice. That's completely what you want to do. If you want to use outside dimensions, instead of making W1 be -1 thickness, you would just make it +1 thickness, right? And that would turn it around.
I think it depends on, if you look at the standards that you have in there, the FEFCO and the other stuff, I think usually they take inside dimension,
yes.
right?
Yes, all the FEFCOs are made via inside dimension. Yeah. And I would recommend that because usually you want to make a box that fits around a product. So you know how big your product is and you want to make a box that fits that. If you're not going to use standard sizes, that would be the case. You would create a box that fits a case you have. Yeah. So in that case, I would recommend inside dimensions. If you want to use outside dimensions on your own design for whatever reason you may have, it's possible. You just have to make your formula, you change the formula in the way that it works that way.
But if I have a pallet and I know what the size of the pallet is, and I know that I want to stack 10 boxes on that in a specific way, then I could measure with outside dimension because it's easier.
Yep, yep, you could do that. There's no option right now I've had this question in support. People are asking, can I just change it and make everything use outside dimension? There is no option for that right now because, of course, all these formulas exist in all these scripts, and they made the scripts, they made the formulas to work with one variable. I bet you could code it to have to allow for 2 inputs and to like change it from inside to outside. You can probably code it that way, but they haven't done so, so it doesn't exist right now. So there is no quick option to switch that around.
So you'd have to make your own version.
Yeah, so you make your own version of the design, and with the more complex designs, it might be a bit of work, but it's always dependent on the value you get for it. If you're going to create a box that you want to use in a whole variety of situations, you have a very nice box design that closes nice, it has all kinds of special features that you created for it, and you want to use that box design for everything that your company is going to package. from small things to big things. You can use the efforts to create a parametric design. You will do that only once, and you can use that to create many, many boxes.
Mm-hmm.
If you're only going to use a box you draw once, then you don't need to lose the time in creating it parametrically. You just draw it correctly when you draw it, and you have it. It's going to save some time.
But what you could do is, if you have a box that you want to use for something, you can just draw it without all the parametrics and then add parametric to it later, right?
Yeah, you can do that too. Yeah, so that's what I did, right? I drew a rectangle with fixed dimensions, and then I just decided to add a width and a height to it. You can do that with complicated packages as well. When this box was drawn, I actually had the backlip box that had a fixed size, and then in the 2D application, I decided to change that. The size that it has at the moment you start the parametric design is the size that it's going to use for default, but you can reset that by just using this input field that we have, not this one, but this one, where we say that the default value is a certain something that will override that and it will change that value.
So you could just start by drawing what you need, and if you find that you create the same thing over and over in different sizes, then you could add parametrics at that point.
Yeah, you could.
So the second question from Leon is one I was going to ask as well. I have two more questions about this. The second one is one I had as well here. If you start in Paclib with a parametric design as you did, you imported it into the 2D editing environment.
Yeah.
But at that point, it becomes a fixed box.
Yes, it becomes a fixed box with the dimensions you entered.
Yeah, and so there is no way to take this parametric design that you have in Paclib and see what the formulas are, or use that as a starting point, so to speak.
The formulas are present essentially in that C# code. That C# code is present in the folder where all of these things are stored. Okay. So if you can just go and find it. I haven't done that myself, but that's essentially how it works. So if we go to the C drive, we have this folder wpicador. I believe in Picador version 10, if you install it natively, it will just be called Picador and not wpicador anymore. That might actually be what this is. Yeah, so that's what this is. So we have this whole bunch of data in here. And everything that has to do with everything is essentially in here. So if we go to Paclib, we get a whole bunch of information. These are languages, templates. Let's see what's in here. All the files that are coded with the C# for the designs are DLLs. So if I go to Picador and I go to, where would it have stored that? Plugins, I think. Yeah, so here it is, these plugins. You can see I have test and I have test and I have something with a very weird name. That's obviously because I've been doing stupid stuff when showing this off in demos. So these are actually the files that we looked at. If I open this with a text editor, WordPad, for example, oh my God, that is not what I expected to see.
File DLL, yeah.
Yeah, so this is essentially what contains that code. Yeah. I don't think there's an easy way to just open up the data that they have stored in it, but it's saved somewhere, so we can probably find it.
But there is no way to just hit a button in Paclib and get a parametric design in the 2D environment that you can modify.
No, the moment we get it to the 2D application, it becomes a fixed size.
Yeah. And then the other question is unrelated to variables, I think, but because you're talking about Paclib, if I create something and I put all the variables correct the way I want them in Paclib, and I want to share that with someone. So now I have a final design and I want to give someone a template or the die lines they can use in Illustrator or whatever to make the design. How do I do that?
So what we can do in Paclib, because it's just a database, if we go to the root, you'll see that I actually have a folder called 4piece here. That's not a coincidence. It's not something that treeDiM has added in for us, especially. I just created that. So what I can do is right-click. I can say new branch. If I make a new branch, I can call this, for example, 4piece Café. I give it a description, designs of, you know what, cool designs. And I can give it a thumbnail. So if I don't give it a thumbnail, it'll just become one of these blank folders. You can see Fevco, ECMA, some other stuff has a pretty drawing. You can add a little JPEG and you can make a drawing if you want it to be. You can add your company logo or something. So now we get 4-piece Café, which is an empty folder. And if I have a design saved up, so let's say I probably didn't save anything. But let's say I just create that rectangle again. And I give it a width and a height. And I create those formulas again. And I tell it, well, my height should be equal to my width divided by 2. Confirm, add that formula. I have to check this again and call this width with a default value. Oh, that's a coincidence. It's just exactly 100 purely by coincidence. Then I can click the generate component button. I can call this rectangle. I can give it a description, rectangle, and I can say generate. Now we should have this file with this stuff when it validates. There we go. It should create that rectangle file in that plugins folder. So let's just have that happen. If I go look there, we should see in that plugin folder, it might not be in this one, but in the other one. Oh, here we go, rectangle.dll, 15th of April, that seems to be today. So what I can do is I'm going to put this on my desktop just to have an easy access to it. Copy it. Oh my God, never mind easy access. Paste, there we go, rectangle.dll is now over here. And if I go to my packlib again, I can say new document.
Okay. So you're adding it to this thing that you created.
Yeah, and then I can create a whole library that contains all my stuff. I can choose a file. So now I can go to my desktop and I can pick that rectangle. We'll get a preview, we'll get this information. I can add a thumbnail if I want to. Again, same thing. I can say, okay, and we will have this rectangle here. And now I can change the values here. I'm not entirely sure why it created 2 dimensions for this, but it doesn't really break anything. So now that I have it here, what I can do is I can export my library or my folder of my library, and I can send that to someone, and someone can import it into their thing, and then they can use it. Or I guess I could just send them the DLL and they can import it into their library. That would also work. So that is a way to do it.
If you're in a company setting and you have someone who designs all the basic templates, then they can do that, put it in a separate folder, and then share it with the rest of the people who need it.
I think even better, I think we can even access the library from a network folder and just have a shared library for everyone.
Yeah.
Because this is just looking at a path that I have entered. And the path right now is looking at, of course, my local drive, but that could just as well be a network drive.
Yeah, and then you could update it on the fly.
Yeah.
Okay.
So that's essentially what I said I was going to do. Talk to you about packlib, how the variables work, and then show them off in 2D, how to create them yourself. Of course, any more questions are welcome. If anyone really wants to see how the Picador treeDiM module works, for example, I don't mind showing that off a little bit. It's pretty cool.
So this is a standard application as well, right? Packlib?
Yeah, Packlib is a standard application.
Yeah.
When you download and license Picador, what you'll actually get, looks like all kind of stuff is staying open, is all of these 4. So you'll get Packlib, the 2D application, the 3D application, and Stack Builder. All of those will be added.
Okay.
Another question I see coming in, can we add our own design from Illustrator, for example, to the library? Yes. How would you do that? Well, you could take the 2D application, which allows for basically any file format in opening. So if we open up a file, well, not on this place apparently, but we should be able to import, file import, and you'll see there's a whole list of file formats that support it. Okay. So if you have designs that are made in Illustrator, if you have designs that are made in another CAD application, they will likely have one of these file formats, DXF, CF2, Illustrator, PDF even. All of these supported file formats, you can just open up files like that. They will ask you to what you want to do with them. For example, if I open a PDF or an Illustrator file, of course, Picador will not immediately say, okay, that's fine, I'll just take it. It will look at what is in the file, and it will look for spot colors and layers, and it will ask you which spot color, which layer relates to which line type. So you'll have to tell it, well, this spot color equals cut lines, this spot color equals crease lines. And then it will be able to import your file, and you'll see it has this importing window, and then it will open up your design in Picador. Something we see a lot with files from Illustrator is that the curves get messed up. So rounded corners often get broken. I spoke to about this with Alain for a while, and he says Illustrator does it wrong. So what has he created? He has a tool in here that will recreate all the curves made by other applications, and it will redraw them with the correct line types that Picador likes, and then it will fix that up. And it's just one button to fix your entire artwork. So if you see that happening, don't worry about it. You can fix it easily. Another such a tool that we have is to remove duplicate lines. You will see in the tools folder, that's where they are. So if we go to, I think it's underneath curve, we have explode all curves. That's the one that fixes all the curve lines. We also have a tool to remove duplicate lines. Let's find out where they keep that, because I'm not entirely sure. Oh, over here on the sides, we have delete duplicate entities that will delete duplicate lines that are present. So you can fix up your drawing pretty easily, and then you can save this as a DES file, so a Picador file, and you can just load the DES file into Paclip and use it there.
Mm-hmm. And can you export back again to Illustrator at the end of all of this?
We have in export is the exact same thing. You got a whole list of formats, and it will do PDF, Illustrator, CF2, and all that. And even better, if you use the spot colors and the layers here, it will keep those spot colors and those layers. So my cut lines will be a spot color called cut, and on a layer called cut. My crease lines will be a crease layer called crease color called cut, crease obviously, and a layer called crease. Yeah. So no matter what you use down the line, if it's a rib that looks at layers, a rib that looks at spot colors, it should work because it does both.
Okay, any other questions from anyone? Now is your chance.
Looks like I was very clear in my explanations.
Yeah. So
or people fell asleep.
There is a trial version of this, right, Michiel?
Yes, there is a trial. It is 30 days, so it's really quite generous in its trial period.
Okay.
So if you want to test this out yourself, you can just get the download from our website or from the treeDiM website, and you can start the trial from inside the application. So if we go to the licensing window, then we will see this is there is a licensing option. So you just say to obtain, fill all this stuff in, and send it to Picador, and they will return to you with a 30-day trial. And then you can test stuff out. And if you come across anything that doesn't work immediately, just send us a message and we can help you out with that. We also do training for this application, of course. If you want to have some detailed training about all of this, not a problem, we can do that.
Yeah, so 2 more questions. Is there documentation about types of formulas? I'm assuming that is about the C#.
Well, it could just be the parametric formulas. So the documentation is sometimes a little lacking, but not in this case. On the treeDiM site, I can actually show you that. It's just, yeah, it should work. treedim.com. If we go to the treeDiM site, we will see this training button on the right. And this training button actually contains a whole lot of chapters. You can see all of these chapters on the right, and it has parametric design part 1 and part 2. And those will actually explain a whole bunch of that. All the rest of it has to do with what are the drawing tools. It's actually really nice. And it has short videos explaining all of this stuff. that go step by step and go all about this. By default, you'll only be able to do up to exercise 1, I think. You will have to use the connection button at the top here to create an account on the treeDiM site to get access to all the rest of it. But I think there's no verification of that or anything. You just fill in your account and you can start using it.
Okay.
Again, if you have questions, go ahead, ask them. And there is a whole PDF manual for that whole thing too. I see another question, hot folder based automation. What would you like to do with the hot folder based automation? Because I'm not sure what your plan with it is.
That needs some explanation, I think, because of course on the design side, most of this really is a design application, which is very hard to automate in that sense.
Yeah, skipping that for a second until we get more information. How to use it on Mac? Well, actually, I am on Mac. So what I do to use it on Mac is to use Parallels VM. So you can see it over here. Parallels is a really nice application for virtual machines on Mac. It's really smooth. It's you can see my rectangle DLL is actually present on my Mac desktop. That's because everything is shared completely. So it's you can use both operating systems simultaneously, and you can share files really easily. It's very smooth. It's not that expensive either. So if you want to go for a VM, I really prefer Parallels over, for example, VirtualBox. Picador doesn't use that many resources, so that means I can run this Windows VM with Picador at the same time as I run my Mac stuff, and usually I don't see much of an impact.
But there is no Mac version now, or that we know is coming.
No, there is no Mac version that exists now. There is no Mac version planned. I think it's just a Windows application completely natively.
Okay, so PDF processing steps supported. I think the answer to that is no at the moment.
Yeah, it creates the layer cold cut and the spot color cold cut. I don't think it does anything else.
No. So at the
but
moment,
I guess if you have that information, you could probably do that with PDF Toolbox.
Yeah, you can do it. You can absolutely do it with PDF Toolbox. You don't even need the layer. You just need the spot colors, and you can already fix it. But of course, it would be if I put on my hat as executive director of the Gantua Group. It would be nice if it would support processing steps, Michiel, but I know it doesn't at the moment.
If we make a file from another application, do we have to distinguish the color of the lines? You have to use spot colors. That would make it very easy. Layers would also work, I think, just layers. But if you make a design in Illustrator, you don't have to. If you make everything in one file, in one line type, it will also import. It will import just fine. But everything you import will be the same line type. So what you then have to do is change the lines in the application. And that's probably slightly more annoying. So if I go here, what I can do is I can just select lines, for example, these two, and I can say, well, these lines are not actually crease lines. I want them to be, well, perforations, for example. If I now go away again, you see these are now perforated lines. So I can change my line types after import if I want to. So you don't have to do it in Illustrator. But if you do it in Illustrator, you can import and you can choose what it has to become, and everything will automatically be converted. So it's going to be slightly nicer if you do it that way.
Okay, and then a clarification on the hot folder automation. This is where I expected this to be going. So integration with Web2Print for creating packaging layouts. So what I'm assuming the question is there any way I can, in a web front end, I can let someone pick a design and then set parameters and end up with a correctly sized box?
The answer to that would be yes, because there is an API for that. So you can actually integrate Picador. I have an example. I am not sure if I have access to the link right now, but I actually have a link of a demo setup that shows that off. So if I can, I'm going to check my email real quick, but I'm not sure if I can find it so easily.
So in theory, at least, while you're looking for that, the answer is yes, there is an API. It is possible to integrate this into an online environment. You would have access to or you could set it up in such a way that you have access to Paclip and that someone can select a design from a list, for example, and then that they have the ability to see what the variables are and so on.
I found the link. So here we are. This is in my browser. So this is just a proof of concept page that shows off Paclip as it would be by default. So I could still go to Fevco and it will open up. So it's slightly slower, but that's of course because it's going via that whole server thing. And since it's a proof of concept, it might not be the most efficient tool available. So I can go to the 200 page. So essentially, if you want to integrate this, there is an API for that. You can do it and it can work. It works exactly as the database of Paclip would. So you can choose a design, you can set the sizes, and you can get the drawing you want from it. So you can get the DXF, the PDF, whatever it is that you're looking for, you can get it out of the system.
Yeah, on the commercial side, I'm not sure what the answer is on that. What I would suggest is to send me a short email and we'll figure it out afterwards. I don't know whether it's included in the license or what type of license we would be talking about in that case. I have to look that up. I'm
not sure either.
That's what happens when you talk to people in a cafe that are on the technical side. We don't know the commercial questions. But it is yes, absolutely. It is very possible. I think don't judge what you see here by performance. This is a proof of concept website, and the purpose was really to show off what the possibilities are. I don't know what kind of cloud environment, well, it's an Azure website, but I don't know what kind of performance the server this is running on or anything like that. So I don't think this is representative for the actual performance if you would do this on a good production server, but it is definitely possible, yes.
Okay. I like that we're seeing so many questions.
I think that were all of the questions so far. Thank you for joining. I hope this was interesting, but judging by the amount of questions, I guess it was. And we will see you at an upcoming cafe.